For the Doctor of Technology degree in Electrical Engineering, our first candidate today is Mtsedo Sandiso Mkondweni. I will call upon the supervisor of the student to read the citation. Professor Tsoneva.
Dear Vice Chancellor, the title of the thesis of Mr. Kondweni, now Dr. Kondweni, is Design and Implementation of Linear Robust Network Control Systems. Mr. Kondweni grew up in the Eastern Cape. After matriculating from Valley Senior Secondary School in 1995, he obtained in the field of electrical engineering his first national diploma from the Eastern Cape Technikon in 1999 with cum laude merit award and merit medal. Second BTech degree from the Peninsula Technikon in 2000 with cum laude merit award and merit medal. And third MTech degree from Peninsula Technikon in 2002 with cum laude and Vice Chancellor medal. In network control systems, the plant and the controller exchange information via a shared communication network. Unfortunately, the network induces randomly varying time delays that degrade the performance of the closed-loop control system and result in its instability. New design methods for a robust predictive optimal controller and a modified predictive discrete Kalman filter are developed to address the problem of the destabilizing effect of the network time delays. The design approach is based on time shifting of the optimization horizon and on state predictors. The time shifting approach allows the design of the controller and the filter to perform for a model without time delays, but the obtained control action is based on the future values of the plant state estimates. The predictor is developed to predict these future values using the present and the past values of state estimates and control actions. The developed methods are implemented for network control of an array of dish antennas, and a co-simulation toolset called LabNS2 is developed to address the problem of real-time measurement of network delays. The thesis outcomes are applicable to control complex and distributed systems in chemical, biotechnological, metallurgical, manufacturing, and space and satellite industries. Thank you.
For the Doctor of Technology degree in Electrical Engineering, our second candidate, Atanda Kamoru Raji, I call upon the supervisor, Professor Khan, to read the citation.
Thank you, Dean. The title of Dr. Raji's thesis was the performance evaluation and improvement of grid-connected technology. Atanda Komoru Raji was born in Osbuku, Osun State, Nigeria. He graduated from the University of Ilorin with a Bachelor of Engineering, honors in electrical engineering, specializing in electronics and communication systems. He completed a dual degree program at the Cape Peninsula University of Technology with a master's degree in technology in electrical engineering awarded by CPUT, and the MSc in electronics from the EFSATI program with École Supérieure in 2009. He registered for his DTech degree in electrical engineering immediately afterwards. He has more than 15 years of teaching experience in higher education, spreading across the landscape in South Africa, and have taught at many institutions, both in Nigeria and in South Africa. He is currently a lecturer and researcher in the Department of Electrical Engineering at the Cape Peninsula University of Technology. The topic of Raji's thesis is the performance evaluation and improvement of grid-connected technology, and in particular looking at transformerless technology. For PV systems to attain grid parity, it requires more than the unsustainable approach that many of the current funding mechanisms that are provided for in government subsidizing the time-limited approach. The technical solution to these problems was to reduce the overall system cost through innovations in transformerless technology. One such method was the adoption of an inverter technology that could interface to the grid without transformer-based systems. The PV topology called full bridge zero voltage reactance AC decoupling dual parallel system was developed and analyzed for this thesis. The topology proved to be efficient and safe when the bipolar switching strategy was adopted, and the German VDE 02611 safety code was used as a base for the requirement to be satisfied for interconnection to grid systems. The development of this novel inverter technology reduced the time to rate of investment returns of PV systems for both large and small interconnected systems, while at the same time increased the efficiency to system cost ratio without compromising the safety of users when we have direct interconnection to the grid in transformerless applications. 2 international peer-reviewed conference papers and journal articles have been published through this research program.
For the Doctor of Technology degree in Mechanical Engineering, candidate Adetayo Samuel Igonjebi, I call upon the supervisor, Professor Daniel Makinde, to come and forward to read the citation.
The title of Dr. Igonjebi's thesis is Analysis of Laminar Flow, Thermal Stability, and Entropy Generation in Porous Channel. Igonjebi Adetayo Samuel grew up in Ikere Ekiti State, Nigeria. He completed his first degree in industrial mathematics at the Federal University of Technology, Akure, in Nigeria in 2004, and graduated with first-class honors, cum laude, He proceeded, he was the overall best student at the university that time. He completed his compulsory one-year service for his nation and then enrolled for a master's degree in 2006 at the University of Ibadan, Nigeria. He graduated with distinction in 2008. During this time, he taught some undergraduate courses at University of Ibadan. He lectured at Bell University of Technology in Nigeria before joining the Department of Mathematics and Statistics at the Polytechnic of Namibia, now the University of Science and Technology in Namibia, as a lecturer in applied mathematics. Igonjebi completed his doctorate in the field of computational fluid mechanics in the Department of Mechanical Engineering and CPUT. Most industrial and engineering flow processes and thermal systems are unable to work at optimal level because of entropy production. His research is focused on modeling and analysis of factors that contribute to entropy production in industrial and engineering systems in order to minimize their effects and enhance the optimal efficiency of such flow processes and thermal systems. His thesis provides a computational tool for entropy minimization techniques in engineering systems. He has already produced 6 excellent publications in international and reputable ISI-listed journals. His thesis received high commendation from the external examiners.
With a Doctor of Technology degree in Mechanical Engineering, the candidate, Ramoshwe Solomon Lebelo, I call again upon Professor Makinde to read the citation.
Yeah, thank you. The title of Dr. Lebelo's thesis, where's Lebelo here? Thank you. The title of Dr. Lebelo's thesis is Analysis of Greenhouse Gas Emission from Reactive Material and its Thermodynamics. Ramoshwe Solomon Lebelo grew up in Amaskra, north of Pretoria, in Gauteng, South Africa. He obtained a BSc degree in 1988 at Northwest University in South Africa, here. Also, a BSc Honors in Chemistry in 1992 at the same institution. He completed his master's degree in Mathematical Technology in 2008 at the Tshwane University of Technology, South Africa. Lebelo registered for a doctorate in the field of thermodynamics, modeling and computations. His thesis focused on the impact of spontaneous combustion in reactive material stockpiles on carbon dioxide emission and oxygen depletion in industrial sectors. Carbon dioxide, the principal greenhouse gas, plays a major part in atmospheric temperature regulation and global warming. The major contribution of his thesis are twofold. Firstly, a mathematical model for estimating the amount of CO2 emitted at any given point in time was developed. Secondly, the thermal stability criteria for a stockpile of exothermic reactive material were determined. The thesis provides a good theoretical framework for integrating available data on CO2 emission in the industrial sector with a mathematical model Moreover, the evaluation of thermal effects of these reactive materials is important in order to ensure industrial safety. This doctoral study has produced 4 publications in accredited referee international journals. The examiner commends the thesis for its innovative research in respect of industrial safety and estimation of greenhouse gas emissions.
For the Doctor of Technology degree in Mechanical Engineering, Rindani Wilson Malatsi, I call upon the supervisor, Professor Bingwen Yan, to read the citation.
The title of Wilson Manaji's thesis is Analysis of Innovative Leadership and the Sustainability of SMEs in the Western Cape Province, South Africa. Randani Wilson Manaji grew up in Venda, where he matriculated in 1992. He relocated to Phalaborwa, where he registered for a course in electrical engineering at a technical college in 1994. Through a bridging course at the Peninsula Technicum, he gained entry into the mainstream program to complete his diploma in mechanical engineering in 1998. In 2000, he graduated with the BTech Mechanical Engineering, then immediately enrolled for a BCom honors degree at the University of Western Cape, which he completed in 2004. He registered for the MTech Mechanical Engineering in 2005 and graduated in 2008. Manaji commenced his doctoral studies in 2009. His thesis analyzed the impact of leadership characteristics on innovation culture within small and medium enterprises in the Western Cape Province. Because of a lack of innovative leadership and poor management skills among SMEs, many organizations struggle to produce high-quality products in order to meet customers' needs. The significant contribution of this thesis are twofold. Firstly, a leadership model was developed to provide substantial guidance to leaders in order to create a culture of innovation within SMEs. Secondly, a proposed mathematical model can be utilized by SMEs to analyze the future trend of their productivity and profitability based on innovative leadership performance. This doctoral studies has produced 6 publications in accredited referred journals, both nationally and internationally. The examiners of the thesis commented favorably on the methodologies and analytical instruments used and the extensiveness of the literature review. Congratulations.
For the Doctor of Technology degree in Mechanical Engineering, Lazarus Rodora, I call upon Professor Makinde again to read the citation.
Thank you. The title of Dr. Rodora's thesis is Laminar Flow in a Channel Filled with Saturated Porous Media. Lazarus Rodora was born in Zimbabwe. He obtained honors and master degrees in mathematics from the University of Zimbabwe in 1994 and 1997, respectively. He also holds an advanced diploma in higher education from the University of the Free State, South Africa. He was employed as a lecturer in the Department of Mathematics at the University of Zimbabwe from 1998 to 2002. In 2003, he joined the University of Limpopo as a lecturer in mathematics. In 2008, he joined Vaal University of Technology at the Department of Mathematics, where he is currently teaching mathematics. Rodora's thesis is in the area of computational fluid mechanics. He investigated unsteady reactive variable viscosity flow of non-Newtonian fluids in a channel filled with saturated porous media. The study of such flows presents a computational challenging problem and has a broad range of scientific and engineering applications. Such flows are encountered in nuclear waste disposal, insulation of buildings, oil and gas production, MHD pumps and generators, automobile exhaust systems, etc. The chemical reactions within such flow systems are inherently exothermic, and as such, the evaluation of thermal effects is extremely important in order to ensure safety of life and property during handling and processing of such fluids. He developed a mathematical model for thermal effects and determined the thermal stability criteria for such non-Newtonian fluid flows. This doctoral thesis was highly commended by the examiner and has produced 4 publications in international DHET accredited and refereed journals.
With a Doctor of Technology degree in Mechanical Engineering, Isaac Takisa, I call upon Professor Makinde to read the citation.
Thank you. The title of Dr. Takaisa's thesis is Modeling the Optimal Efficiency of Industrial Labor Force in the presence of HIV/AIDS pandemic. Isaac Takisa grew up in Zimbabwe. He obtained his BSc honors and MSc degree in mathematics from the University of Zimbabwe in 1994 and 1997, respectively. He was then appointed as a lecturer in applied mathematics at Bindura University of Science Education in Zimbabwe. Later, he worked at the University of Limpopo, that was University of the North, Teflop, South Africa, as a lecturer in the Department of Applied Mathematics. Currently, he is a lecturer in the Department of Mathematics at the Vaal University of Technology, South Africa. In 2010, Takisa completed his advanced diploma in higher education at the University of Free State and subsequently enrolled for D.Tech at CPUT. Takisa registered for his doctorate in the field of engineering systems, modeling, and computation. Owing to the prevalence of HIV/AIDS, most industrial organizations struggle to improve their productivities and the efficiency of their industrial labor force. The significant contribution of these theses are twofold. Firstly, A mathematical model was for optimal control strategy to enhance productivity and labor force efficiency was developed, taking into consideration the prevailing HIV/AIDS pandemic at workplaces. Secondly, a cost-effective analysis aligned with each strategy for optimal productivity was determined. The thesis provides a good framework for integrating available data on HIV/AIDS with a toolkit of mathematical methods, which can be continuously improved in accordance with the ever-changing picture of the HIV/AIDS pandemic in the engineering sector. This doctoral study has produced 5 publications in accredited referee journals, both nationally and internationally. The examiner commends the thesis for its research innovativeness with respect to HIV/AIDS at workplace and its outstanding contribution to the productivity and efficiency of the workplace.
Ladies and gentlemen, we have almost reached the end of our proceedings, except for 2 awards that we wish to make here tonight. Firstly, it is customary that the Faculty of Engineering award the Dean's Medalist to the top performing student in all disciplines. I would like to call upon the awardee to come forward to the podium. Alexander Ibn Esa Christian. While he's still walking, Alexander was born on 25th June 1992, in his hometown, of course, Engele Village, Namibia. And he's the 3rd eldest of 7 kids. He had a happy childhood, close relationship with his mom and family. He attended Ochikoto High School and, as expected, was usually in the top 10 throughout his career, his schooling career. He completed his National Senior Certificate in 2009. Apart from just studying and more studying, he also enjoys the social life, which is actually true, and likes a game of volleyball. Alexander started his National Diploma in Electrical Engineering in 2010. He obtained distinctions in all, this I was told, 27 out of 23 subjects. And he is currently registered for his bachelor's degree in electrical engineering. And I wish to present to Alexander the medal.
please.